Hello and welcome to Measures of Spread. I handed out two sheets today. One had this data on it here that you can see, and here is a graph of the data. Imagine this is a number line, kind of along here. Okay, and and this is another number line along here, right? Now, there's several things about the data that you should notice. So the top section, the top set of data here, is the inbound data. So in other words, we've gone on fall trip, and here is the outbound data. In other words, we're heading out on fall trip. So this is pre-trip and post-trip data. Now, there's a couple things you can notice. One is on the whole, the heart rate of the post-trip, right, we can say is a lot lower. We can guess that the mean and measures of center are lower, right? And then the pre-trip, right, heart rate data, you can see that the measures of center may not be quite that high, but you can see that it's spread out quite a bit, and it goes all the way from here to here. And whereas this set of data only goes here to here. Now, what we're going to look at is this idea of a couple ways to quantify that difference in spread. So we're going to look at what's called measures of spread. Type that in there. And there's two main measures of spread. One of them is range, which most of you guys are probably familiar with, and the other one is standard deviation. And we're going to look at those two measures of center. So let's go ahead. So you can go ahead and go to the first page there and fill out all this, because this should be review for everything. Okay. We do have, just so if you want to check all your answers, here is kind of the mean, median, and mode and all that information. Okay, so you can check your answers after you're done. So pause the video and pause the video and do this first sheet and then come back. Next, all right, so let's turn to page 2. Another aspect of the data is how spread out the measures are, which is our main thing that we're learning today. Okay, and the first one that we're going to talk about, which should be all pretty familiar with, is called range. Range is the distance from the max to the min. Okay, so let's look at the outbound data. My min is 69. My max is 98. And, oops, tab, 69, which gives me a range of 29. Right, so you can see that's a pretty good range there. The next one, my max is 70, and my min is 60, which gives me only a difference of 10. So you can see that the range of one of them is almost 3 times as big as the range of the others. Okay, two sets of data can have the same range, but the data sets can be spread very differently. So we also look at the average difference between the data points and the mean. So put that in, and the mean. Okay. Now, so the average distance between there and the mean. So let's take a look at what that means. So if you look at these, right, you can see all these. If I drew in my mean, right, which in this case, in the case of the outbound data, my mean was 64.83, okay, which would be about right here, right, 64.83, okay. Now the first thing we're going to talk about is deviation, which is the distance between the data point and the mean. And so this data point would have this distance between the data point and mean, and this distance would have this data point between there and the mean. Okay. Now you can see that the mean in this one, 84, right, you can see has a bunch of different or actually it's 81 point something or other, I think. So let's move this over a little bit. All right. So that you can see how the distances are going to be much greater from the data point to the mean. So that's what we're looking at here. So let's go in here and we're going to type in a few data points and we're going to actually look at how much deviation it is. So I'm going to go ahead and I'm going to pause it and type in all these data points. All right, so let me show you what I've got going here. So here are my outbound data over here, right? And then what I've done is I've found the deviation. Okay, so what I've done is I've taken each data point, right, because that's what this means, data point, and I've subtracted the mean. So I've said 77 minus 81.7 equals this. So now what that means is that this data point, 77, is less than the mean, and so you end up with a negative deviation. And then I went down here and did that with each one. So here's the data point 78 subtracted, and the deviation is the distance that this is from the mean in the negative direction. If we go back and look at look at my graph here, right? So there's my mean right there, right? Here is 77 is this data point right here, okay? And that mean, that difference there is that negative 4 point something something. Now, one thing that's important to realize is that all of these are rounded. Okay, the mean isn't 60. The mean isn't 81.7. It's 81.666666666666. Now, if you in fact go in and didn't round anything, when you add all of these numbers up, right? So we're going to take the deviation and we're going to add them all up. Okay, if I add them all up right now, that sum is going to be 0. Okay, now right now if you add them all up, it's going to be like negative 0.2 or something like that because of the rounding. Okay, now what I want you to do is I want you to go in here and fill in all the inbound data points. Okay, and I want you to find all the deviations for here. So pause the video and take care of that. So these are the deviations that I got right here. Right here. So you should check yours and make sure that they're correct. Now you'll notice that when I added those up, I got a sum of 0 again. Actually, I got 0.00001 blah blah blah. But that just has to do with rounding error. It should equal 0. Now, so let's go down here and look at this. Can you find the average deviation given the sum of the deviations? So what's 0 divided? So to find an average, right, we would add them up and then we divide by the number. Well, when we add these up, they equal 0, right? So we cannot find an average when the sum is 0. Got to get that back on the screen there. When the average is 0, when the sum is 0, right? So how could we find it? Well, that's the big question. So the next thing we're going to talk about is how do you find it? Well, what we're going to do is make them all positive by squaring them. So let's shift over to the next page. Now, here's an example of what I worked at. So standard deviations, statisticians agreed on dealing with this fact that the sum of the deviations will always equal 0, by squaring the deviations to make them positive, right? Because we all know that when we square something, it will make the individual deviations positive. So here are the steps for finding the standard deviation. First, we're going to find the deviations by subtracting the mean from the data point. We just did that. Then we're going to square the deviations and find the sum of the squared deviations, and divide by the number of data points minus 1. This is called the degrees of freedom, and we divide by n minus 1 instead of n because we want to overestimate instead of underestimate. And then we're going to finally take the square root. And here's an example. Okay, and here's the formula. Remember, this means added up and all that stuff. So here we go. So first I have this data set, right? And I found the mean to be 5. And this is just a random data set that I have created. Okay? And so I found all my deviations. Okay? And then I take those numbers and I square them. So in other words, this deviation was -2. Okay? I take -2 and I square it and I get 4. Do it again, 4, 1, 1, 4, 4, right? All this adds up to 18. Okay? So then my next step is divide by n minus 1. So there were 1, 2, 3, 4, 5, 6 members of this data set. Okay, so I'm going to divide by 5. So 18 divided by 5 is 3.6. Then I take the square root because I want to undo the squaring that I did earlier. The square root of 3.6 is 1.9. In other words, each data point is on average 1.9 away from the mean, on average. So now we have an average deviation. Right, and that's how you find the standard deviation. All right, so now let's find the standard deviation of our data set. So what I've here is I've brought in my data, and you can fill this in too. And then I brought in my deviations, which is the data point minus the mean that we found on the other page. And I brought that information over here. Then this is the square, this column is the square of that deviation. So in other words, negative 4.67 squared is 21.8, and so on down the line. Okay. So now the next step is we've squared our deviations, then we add them up. We sum that square, which ends up being 601.3. Okay. Then we divide by n minus 1, so that ended up being 120.26, and then we found the square root, which was of that. So my standard deviation for my outbound data set was 11. Let's go ahead and in this column, why don't you fill in, find the squares of these numbers, then you're going to find the sum and put that sum here, and then you're going to divide by n minus 1 and then take the square root. Alright, so take a second, and here are my data points for the inbound data. Okay, my deviation squared for the inbound data. Here is my sum, rounded pretty heavily. Here is my divided by, this is 669 divided by, or 66.9 divided by 5, once again, because we had those data points. And then this is the square root of 13.47, or 13.4. So my standard deviation for the inbound data was 3.7. My standard deviation for the outbound data was 11. So which group had a higher standard deviation? Well, the outbound group with 11, right? And once again, it is almost 3 times as much. So much wider spread set of data. So now I want you to go ahead and turn to the next page, and you can start your homework. And realize that we won't be doing this. This will be the only time that we do this by hand. And make sure and bring your calculator to the next class so that we can learn how to do it on the calculator so that we won't have to go through this again. Thanks a lot.